Hey, what's up guys? Evan Minton here, bringing you another Christian apologetics video. This is a series of videos in which I'm doing a defense of the Kalam Cosmological Argument. In the first part, I gave a basic introduction of the Kalam Cosmological Argument. I listed the premises, and I gave support for the premises, which are up here on the screen. 1. Whatever begins to exist has a cause. 2. The universe began to exist. 3. Therefore, the universe has a cause. Then, in the next video, I gave a list of objections that atheists have to premise 1. And we saw that those objections were not very good. In this video, I'm going to be responding to objections that atheist philosophers, scientists, and even the internet atheists that you find on Reddit and Facebook have to the second premise of the Kalam Cosmological Argument, which is that the universe began to exist. Does the second premise of the Kalam really stand up under scrutiny? Let's look at the evidence. Fire up those neurons, because we're about to use the brains that God gave us. Objection 1. The Mother Universe Theory. A model was developed in the 1970s that is popularly called the Mother Universe Theory, or the Bubble Universes model. It says that there is a mother vacuum which spawns all sorts of baby universes in its womb. The mother universe is said to be static and eternal. It's just the babies that have a beginning. The mother universe is a changeless and eternally existing thing. These smaller universes expand into the great vacuum in which they exist, similar to how bubbles expand inside of a bathtub as you agitate the bubble bath liquid with high water pressure. According to some atheist scientists, this gets them out of concluding that God created the universe because the Big Bang may have just been the birth of one of these bubble universes, and the cause was the bathtub universe rather than God. This model has serious problems. You see, at any point in the quantum vacuum, there is a non-zero probability that a universe would form at that point by a quantum fluctuation. But given infinite past time, universes will have come into being at all places in the quantum vacuum, because given any non-zero probability and enough time, eventually that probability will be actualized. In that case, by now, all of those universes will have gotten so big that they would all fill the entire vacuum and collide with one another, join together and form a massive universe that gives the appearance of an infinitely old, infinitely large universe. This is in contradiction to the powerful scientific evidence that tells us that we live in a universe of finite size and age. So as you can see, it's not enough for these bubble universes to expand in the unchanging mother universe. In order to avoid having the appearance of an infinitely old, infinitely large universe, the mother has to be increasing in size as well. But if the mother universe were constantly expanding, then the Vilenkin Theorem would apply to it, and that means that the mother universe had to have a beginning to its existence, and ergo would require a transcendent cause. Now, some of you may be wondering, what is the Vilenkin Theorem? The Vilenkin Theorem is a theorem published by Arvin Borde, Alan Guth, and Alexander Vilenkin. Their theory says that any universe which has been, on average, in a state of constant expansion cannot be infinitely old, but must have had a beginning at some point in the past. The Borde-Guth-Vilenkin theorem even applies to a mother universe that produces many baby universes. Vilenkin writes this on page 176 of his book, Many Worlds in One. Quote, "It is said that an argument is what convinces reasonable men, and a proof is what it takes to convince even an unreasonable man. With the proof now in place, cosmologists can no longer hide behind the possibility of a past eternal universe. There is no escape. They have to face the problem of a cosmic beginning." End quote. Additionally, the Mother Universe suffers from the same issues of the absurdities of actual infinites that I argued in my first video that led to the conclusion that this universe had a beginning. Physicist John M. Kinson explains that, quote, P1, if atheism is true, the universe must have always existed. P2, the Big Bang shows that the universe did not always exist. P3, therefore, atheism is false. P4, to avoid this conclusion, that atheism is false and God exists, many leading atheists prefer the conjecture that our universe was birthed by a mother universe. P5, so what created the mother universe? One atheist conjecture is that the mother universe always existed. P6, however, this means that the mother universe must have crossed an infinite number of moments of time to get to the instance when it gave birth to our universe. P7, however, it is impossible to cross an infinity of time moments by crossing or counting through them one by one sequentially. No matter how long you count, you can never cross infinity. P8, therefore, the grandmother universe cannot be infinitely old. P9, therefore, the grandmother universe was created a finite time period ago. P10, this reasoning shows that the grandmother universe did not always exist. P11, therefore, the superset universe, defined as including grandmother universe, mother universe, and our universe, did not always exist. P12, therefore, atheism is false, similar to P3 above. C1, therefore, atheism is false. C2, therefore, there is a God who created the universe, or the mother universe, or the grandmother universe, end quote. In conclusion, the mother universe theory can't be the escape hatch from God that the atheist wants it to be. If there were an eternally old universe, each spawning babies, there's a non-zero probability that at any point in the mother universe, a baby would Big Bang into being. Now, given that this has been going on from eternity past, and given that a non-zero probability and an infinite amount of time, any non-zero probability event will occur, this means that at every single point in the mother universe, a baby will have spawned and expanded, which means that all of these babies would eventually get so large they would cobble together and form one infinitely large, infinitely old universe, or what appears to be an infinitely large and infinitely old universe. That contradicts the evidence that we live in a universe of finite size and age. But if the atheist wants to say, okay, well, the mother universe is not static, it's increasing in size, so there's always more room to accommodate each of the babies. Well, in that case, the Vilenkin Theorem applies to the mother universe, and the mother universe had a beginning. Now, if the atheist wants to say, okay, there's a grandmother universe, and the grandmother universe is spawning babies, one of those universes was the mother that produced our universe. Well, same problem. If there's a grandmother universe that's eternally old, it's been producing baby universes from eternity past, there will have been a baby universe that formed at every single point in the vacuum grandmother universe. Because given a non-zero probability of any event and an infinite amount of time, just given enough time, it will occur. So therefore, again, all the babies will cobble together, form what looks to be an infinitely old, infinitely large universe. If the atheist wants to say, no, okay, the grandmother universe is expanding, bam, Vilenkin Theorem applies to it, and the grandmother universe had a beginning. Well, what about a great-grandmother universe? Same problem. Not to mention that if any eternally existent mother, grandmother, great-grandmother, great-great-great-great-great-great-grandmother universe suffers, as John Kinson pointed out, from the problem of having to cross an infinite number of moments before the moment in time in which it birthed our universe. So, this theory, I believe, is the best objection to the second premise of the Kalam, but it doesn't avoid an absolute beginning of all physical reality. At best, it just pushes it farther and farther and farther back. And we know, given the first video, you can't traverse an infinite number of things, so there can't be an infinite series of superset universes just going on and on and on forever, which give birth to babies themselves. There has to be an uncaused cause, a cause that transcends all matter, energy, space, and time. Objection 2. The appeal to the First Law of Thermodynamics. The First Law of Thermodynamics states that matter can neither be created nor destroyed. So the objection here is that if matter can neither be created nor destroyed, and the Kalam argument entails the doctrine of creatio ex nihilo, that's Latin for creation out of nothing, then it follows the argument is fallacious. There are 3 problems with this rebuttal. Number 1, the evidence suggests that the universe did have a beginning. Pointing to the laws of thermodynamics does not overturn the evidence. In the first video, we saw a ton of evidence that the universe did begin to exist out of nothing a finite time ago. The atheist cannot simply appeal to the first law of thermodynamics and ignore all of these various pieces of scientific and philosophical evidences that the universe began to exist. He has to take all of the evidence into account. Second problem with this response is that the laws of physics don't apply if there are no laws of physics. Let's think for a second. What if nothing at all existed? What if there was not a single solitary thing in existence? No matter, no energy, no space, no time, nothing. Would the laws of physics apply? Well, the laws of physics are something, not nothing. So in this state of nothingness we are imagining, the laws of physics would not apply. They would not apply because they don't exist, or they wouldn't exist. The laws of thermodynamics came into existence along with the universe. They weren't sitting around someplace waiting for matter to be created so they could rule it. God created ex nihilo, and because that means from nothing, that eliminates the physical laws, which are something. If there is nothing, there is no thing, and that includes laws. Third problem with this response is that the first law applies to nature, not God. We need to keep in mind that matter cannot be created or destroyed by anything natural or physical. Nothing in nature is going to produce something ex nihilo. However, this doesn't apply to something supernatural. God is omnipotent, and as such, he can do anything that's logically possible. There is nothing logically impossible about bringing something into being out of nothing, without any prior existing materials. God created the first law, and as such, he has power over it. It doesn't have power over him. I submit to you that the first law of thermodynamics, like all other natural and physical laws, only applies post-creation. They do not apply pre-creation. The first law of thermodynamics was not in force before the universe existed, any more than gravity or electromagnetism were in effect. In conclusion, the first law of thermodynamics isn't a problem for the Kalam Cosmological Argument. Objection 3. Your argument for the finitude of the past is fallacious because in an infinite past there is no event infinitely distant from the present. This is a rebuttal to the second philosophical argument for the second premise. The objector here is arguing that any point within the infinite past is only a finite distance from any other point in time. So you could conceivably get from one point in time to another from another, since only a finite number of points need to be crossed. The problem with this argument is that it commits the fallacy of composition. What is the fallacy of composition? The fallacy of composition is when someone infers that the whole of something has a certain property because a particular part of it has a property. So if someone said that an elephant is lightweight because every part of the elephant is light in weight, they would be guilty of the fallacy of composition. Just because every part of an elephant is lightweight, that doesn't mean the entire elephant is light in weight. The objector is arguing that because it's possible that the finite distance between two intervals can be traversed, that therefore the whole infinite series can be traversed, and that therefore my argument for the finitude of the past is invalid. What I argued was not that any two finite intervals in the series of past events couldn't be traversed, but that the entire infinite beginningless series couldn't be traversed. Obviously the former can be done, it's just the latter cannot be. Just because every finite part of the series can be crossed, that doesn't mean that the whole infinite series can be crossed. Objection 4. We don't know what the 10 minus 43rd second of the universe was like, so we can't say whether or not it had a beginning. This objection says that since scientists have no idea what the conditions of the physical universe was like during that billionth of a billionth of a billionth of a second after the Big Bang, then this makes the existence of a cosmological singularity guesswork. We really can't say whether or not the universe had a beginning because at 10 minus 43rd of a second after the Big Bang, which scientists call the Planck Era, we have no idea what the conditions were like. At this stage in the universe's history, the current laws of physics break down. Is this really an obstacle to affirming that Kalam's second premise is true? I don't think so. All we need is for the universe to be expanding, and we can conclude that the universe came into being a finite time ago. Whatever the universe was like prior to that 10 minus 43rd second of its existence. I say this on the basis of the Vilenkin Theorem. Dr. William Lane Craig explains that, quote, something of a watershed appears to have been reached in the year 2003, when three very famous cosmologists, Arvin Bohr, Alan Guth, and Alexander Vilenkin, were able to prove a theorem which shows that any universe at all which is in a state of cosmic expansion on average throughout its history cannot be eternal in the past, but must have had a past space-time boundary or beginning of its existence. What makes the Bohr-Guth-Vilenkin theorem so remarkable is that it is independent of any description of the universe prior to the Planck time. That is to say, it doesn't depend on having a quantum theory of gravity for its validity. Because we do not yet have a physical description of this early era of the universe, it has been fertile ground for speculation. In fact, one scientist has compared this to regions on ancient maps, which are labeled, "Here there be dragons." You can fill in all sorts of imagined fantasies. But the Bohr-Guth-Vilenkin theorem implies, whatever physical description we come up with for the early era of the universe must have had a beginning at some point, at some time in the past. End quote. To put this in the form of a mathematical equation, expanding universe plus Bohr-Guth-Vilenkin theorem equals a universe with a beginning. The fact that we don't know what went on during the Planck time of the cosmic expansion has no bearing on whether or not we can know that the universe began to exist, nor does it have any bearing on whether we can know what caused the universe to come into existence. By way of analogy to see how silly the skeptic's reasoning is, suppose 3,000 years ago, way before anyone knew anything about embryology, someone argued that humans have an absolute beginning to their existence, and pointed to real examples of women giving birth to show that humans begin their lives as babies, and they grow bigger over time. Any notion that babies always existed in their mother's womb is refuted by the fact that the farther back in time you go, the smaller the woman's stomach gets. The baby beginning argument proponent goes on to argue that 1. Whatever begins to exist has a cause. 2. Humans begin to exist. 3. Therefore, humans have a cause. After this, the baby beginning argument proponent then goes on to bolster step 3 by saying that sexual intercourse between a man and a woman is the best explanation for what the cause of babies are. Now, imagine that a skeptic comes along and says, but we have no idea what goes on inside the womb for those 9 months prior to birth. Maybe sex isn't the cause of babies. We can't say that for sure, since we don't know what happened during these earliest moments. Obviously, such a response is absurd. The fact that they don't know what the fetal development period is like is no reason to conclude that they don't know whether or not humans have an absolute beginning to their existence. Now, I realize that arguments by way of analogy are prone to attack. Detractors usually go after all of the different ways that the analogy is different to the thing that it's being compared to. But that's the case with all analogies. If the analogy was 100% identical to the thing that it was being compared to, they would cease to be analogies. By the law of identity, they would be the exact same thing. The point of this analogy, analogies just have to be close enough. They just have to be close enough. And the point of this analogy is that just because you don't know what the earliest period of X was like, that does not entail that you don't know A, whether or not X had a beginning, or B, what the cause of X's beginning was. Now, if you don't like the embryonic analogy, maybe you'll like these apples, literally. When I was talking about this objection in the Facebook group, the Christian Apologetic Support Group, a person named Robbie Hales commented this, quote, "This hyperskepticism really doesn't apply to anything else, so why the Big Bang? It's like saying we can't know that an apple is going to fall when you drop it because we don't know the right mathematical theorem to describe quantum mechanics. But it's really worse than that, because at least quantum mechanics, there's a good chance we'll figure that out. But with the Big Bang science, we literally can't go any further back than Planck time, which is why the latest theories that come out are more philosophical and metaphysical in nature than they are scientific." So for someone like the person in this video, and that was a video which someone brought up this objection, no amount of scientific evidence will convince them, because in order to be convinced, they are waiting for science to explain something that is literally impossible for scientists to explain. The beginning of the universe just is the beginning of science. And then objection 5. What about the oscillating universe model? One model championed by scientists was the cyclical model of the universe. Now, this model is not positive. I don't know very many people who hold this model anymore, but I'm just addressing it just in case there's people out there who, some outliers who are still holding on to it. And this theory stated that the universe is going through an eternal cycle of expansions and contractions. The universe would expand from a tiny dot, and then it would collapse, and then it would re-expand from that tiny dot, and then re-collapse, and then re-expand, and then re-collapse. You'd have a big bang, a big crunch, a big bang, a big crunch, and so on, and so on, and so on. This could have been occurring from eternity past. So this was an attempt to explain the observation that the universe is expanding from a singularity point, but also to avoid an absolute beginning and the theological implications that has. Now, there's a reason why this theory is hardly held by any astronomers or physicists anymore. This is because the theory is plagued with several problems. The first problem is that even if the universe were to someday contract, no one knows of any potential bounce mechanism which would cause the universe to undergo another expansion. Secondly, the universe currently isn't dense enough for gravity to cause a retraction of the universe. Thirdly, even if the universe did have a mechanism which would cause the universe to bounce back from a retraction, and even if the universe were dense enough for gravity to pull the universe back to a singularity, the amount of energy in the universe would be replenished. What that means is that whatever amount of usable energy the universe contained on one round of expansion, it would have that exact same amount of energy on the next round of expansion. What this entails is that the energy required to cause a bounce mechanism to start new expansions after each contraction would run out eventually. And thus eventually there would come a time when the universe would have no more energy to cause another bounce, another Big Bang. You would have a final Big Bang, and the universe would just expand on into eternity. But if you have a final Big Bang, that means you had to have a first Big Bang, and hence the universe is not eternal. As an illustration, consider what happens when you drop a rubber ball. The rubber ball has enough energy for it to bounce back several times, but it loses that energy each time it makes contact with the ground. After several bounces, it comes to a complete halt. That's a good analogy for what the universe would do on a cyclical model. Given that the bounce mechanism of the universe would use up more energy after each cycle, the size of the expansions would get smaller and smaller and smaller after each bounce. Fourth problem, the infinite regress problem. The fourth problem is not so much scientific as it is philosophical. What the cyclical model proposed is just simply impossible, and if you've watched my first video on the Kalam Cosmological Argument, you'll know what I'm talking about. You cannot have an actually infinite number of past events. You cannot traverse an actually infinite number of things. Because if that were the case, the present would never have arrived. On the cyclical model, before this expansion round could occur, the expansion round before it would have to occur. And before that expansion round could occur, there had to be an expansion round before it that would have to occur. And before that expansion round could occur, an expansion and contraction before it would have to occur. And before that expansion and contraction could occur, there would have to be an expansion and contraction before it. And so on, and so on, and so on, and so on. And no expansion and contraction could ever take place because each round of expansion and contraction would have an actually infinite number of expansions and contractions that would have to come to pass first. So at the very least, there could only have been a finite number of expansions and contractions. But according to Occam's razor, which says that you shouldn't posit phenomena more than what is necessary to explain the event in question, I would say that we shouldn't even posit any number of rounds of expansions and contractions at all. The first Big Bang was the only one this universe experienced. Objection 6. What about the steady state model? This theory was proposed in 1948 by Fred Hoyle and Thomas Gold. According to this model of the universe is expanding all right. However, its appearance never changes because as the galaxies recede from one another, new matter comes into being and takes the place of the matter that used to be there. This theory isn't held by many scientists anymore either, any more than the oscillating universe model is. There was never any experimental verification for this theory. It was always trying to explain away the facts, then make verifiable predictions. It never explained any experimental predictions that the theory uniquely made. Additionally, the observation of galaxies that were much farther out demonstrated that there were more radio galaxies in the past than in the present. Therefore, it demanded that the cosmos has not been in a steady state after all. The biggest problem for the steady-state model was the cosmic background radiation discovered in 1965 by Arno Penzias and Robert Wilson. Scientists predicted that if the universe is expanding from a hot Big Bang beginning, then there should be residual radiation pervading the cosmos. This residual energy was confirmed by accident when Penzias and Wilson were experimenting with the Holmdel antenna. Everywhere they turned the antenna, they picked up static. Initially, they thought that the static was being caused by bird droppings, so they cleaned up their equipment and started scanning the skies again. But they still found that they were picking up this weird static. It turned out that the static was the cosmic microwave background radiation predicted by the Big Bang Theory. In other words, the radiation that scientists said should exist if the Big Bang Theory were true. Well, Penzias and Wilson discovered it. Penzias and Wilson won the Nobel Prize for this discovery in 1978. No condition of a tiny universe, billions of degrees in temperature, existed on the steady-state model. This was only compatible with the standard Big Bang model. Given that, the steady-state model was refuted and abandoned in favor of the Big Bang model. Objection 7. What about the Carroll-Shin model? In 2004, Sean Carroll and Jennifer Shin published this model in a paper titled Spontaneous Inflation and the Origin of the Arrow of Time. I'm going to read from an article, an online science article, that briefly summarizes what this model is all about. This is an article written by WebDesk on SciencePageNews.com, and first he points out that the theory was first proposed by Sean Carroll and Jennifer Shin. Sean Carroll was, at the time of the writing of this article, a professor at Caltech. I don't know if he still is a professor there or if he's moved on to something else. And Jennifer Shin is a graduate student in 2004. And they propose that time moves forward because of the contrast in entropy between then and now, with a distinction on the fact that the future universe will be much more disordered than the past. This movement trends towards high entropy and gives time its direction. And then Desk writes, quote, "The latest theory by Julian Barber from the University of Oxford suggests that a low entropy level in the early universe is inevitable due to the forces of gravity, and eventually that's what gives time its arrow. To test this idea, the theory's advocates assembled a simple model with over 1,000 particles and the physics of Newtonian gravity. Lee Billings from the Scientific American explains, the system's complexity is at its lowest when all the particles come together in a densely packed cloud, a state of minimum size and maximum uniformity, roughly analogous to the Big Bang. The team's analysis showed that essentially every configuration of particles, regardless of their number and scale, would evolve into this low complexity state. Thus, the sheer force of gravity sets the stage for the system's expansion and the origin of time's arrow, all without any delicate fine-tuning to first establish the low entropy initial condition. But there is a twist. The expansion that occurred after the simulated Big Bang didn't just take place in one direction, but two. The basic Big Bang they modeled produced two universes. Second, one possibly a mirror of the first." And then he goes on to, basically, the Big Bang split, and it went in one direction of time, and in the other direction, and then in another direction, we have like a parallel universe identical to ours that is sort of playing in reverse. It's like everything is happening that's happening in our universe, but it's happening backwards. That is the gist of it. Now, does this get out of the Kalam's conclusion that a non-spatial, non-temporal, powerful, uncaused personal creator created everything? Well, no. If you look at the diagram that depicts Carroll and Shin's model, you can see that even on this model, there is a common point of origin for both streams of time, both universes. there's a common origin point from which both spread out. It's kind of like, when men pee, and sometimes the stream splits into two directions. That doesn't mean that the urine stream doesn't have a cause. It came from you, dude. It came from you. So likewise, the origin point of the split-streamed universe has a common cause, and I don't see why that common cause couldn't be what we would call God, or what the Kalam shows us as a spaceless, timeless, immaterial, powerful, uncaused, supernatural, personal creator. Moreover, the model cannot be going in both directions infinitely, because as we saw in the last video, actual infinites cannot exist, because if they could exist, then a lot of absurdities would result. Think of the Hilbert's Hotel example that I got from William Lane Craig and talked about in the first part of this Kalam video. So I don't think that Carol Shin's model... There are other problems with the model, but for the sake of this video not being longer than it needs to be, I'm just going to leave it at that. I'm just going to point out that they both universes have a common origin point, and I don't really see how this avoids the beginning. Some of the other problems that the Sherrilkin model has, check out my blog post, Eternal Universe Models Going for the Philosophical Jugular, and check out William Lane Craig's debate with Sean Carroll that is available for free on YouTube. Section 8, the B theory of time. The B theory of time is kind of like... It's a different theory of time than the A theory of time. The A theory of time says temporal becoming is real, the past and the future do not exist in any meaningful sense. But the B theory of time is all moments of time are equally real. It's kind of like a film reel, where every moment on the movie is real. You may experience before and after as the movie plays on your TV or your DVD player or your smartphone or whatever, but that's just an illusion. Temporal becoming is not real if the B theorists are correct. There is the past, the present, the future, it all exists. It's sometimes called the static block theory. Well, I went to Clemson University a couple of years ago to hear William Lane Craig give a lecture on arguments for the existence of God, and I got to ask a question there. Now, I'm not going to play the clip because I'm not sure if the length of time it takes for him to answer the question is fair use or not, and I just don't want to risk it. But I'm just going to summarize what Dr. Craig said. You can go over and listen to it for yourself if you want to actually hear him. I come in and I ask my question at about 1 hour and 40 minutes in. But basically he said that he's talked to B theorists, and they don't think that it's a problem for the Kalam, because if you have a film reel, if you have this moment, all of the moments of time are equally real, and at one moment there is no horse in your living room, but then a little bit later on the timeline, there is a horse in your living room, B theorists would say, well, obviously there has to be a cause for why there's a horse here, but not here. Why is there a horse here, but not here? There's a cause. Likewise, even if the B theory of time is true, the Big Bang is still a scientific fact. The front edge of the universe had a cause, something, just as everything else on the timeline of the static block universe has causes and effects. My parents are the cause of my existence, and my grandparents were the cause of my parents' existence. The law of causality doesn't magically vanish because you think, oh, it's the B theory, temporal becoming is not real, so I guess cause and effect is not real. No, that's a non sequitur. So if we would still inquire as to who someone's parents were, or why there's, who took the cookies from the cookie jar, if we would still ask causal questions within things on the timeline, the static block universe, then why wouldn't we ask that question about what caused the front edge of the timeline? What started the thing? What I'm saying is that even if the universe is like a film reel, the film had a director. The film had someone who put, I guess I'm pushing the analogy now, but it had someone who put it in the film projector and pressed play. So, yeah. Those are the 8 objections to the second premise of the Kalam Cosmological Argument that are the most common. I'm sure there are others. If you have an objection to premise 2 that I haven't addressed, leave it in the comment section, and maybe I'll do another video specifically dealing with that objection, or maybe I'll just interact with you in the comment section, or maybe both. So if you like the video, hit the like button, subscribe, and also turn on notifications, because that way you'll be notified every time I put out new content, and you won't be at the mercy of YouTube's algorithm. Also, I would very much appreciate if you became a Cerebral Faith patron. Patreon is really helped me go far in the ministry because, sometimes you need funding, but you get some good stuff in return too. You get all of these YouTube videos, early access, several days before the public. You get early access to my blog posts. You get early access to the podcast episodes. You get shout outs on the podcast and on my YouTube videos. You get all of my Kindle books. You get, if you're on the $10 tier, you get Patreon exclusive audiobooks that you can't get these on Christian Audio or Audible or anywhere. You can only get them through Patreon. So if you want an audiobook adaptation of My Redeemer Lives, or The Case for the One True God, or my upcoming book, which I hope to get out before the end of July, Yahweh's Inferno, then you need to become a patron. Otherwise you won't be able to get those audiobooks. So thank you for watching, and until the next time, keep using the brains that God gave you. Did a little fawns thing there. Don't know why. Peace out.